Hello friends, welcome to 10th standard mathematics video lessons. In this video, we are going to learn how to prove first theorem from circles chapter, and this is Jyotikumar M. Let us move on to statement of first theorem from circles chapter. The statement is like this. The tangent at any point of a circle is perpendicular to the radius through the point of contact. Before going to further steps, let us recall what are the definition of a tangent and a point of contact. A straight line which touches the circle at only one point is called as a tangent, and the point where a tangent touches the circle is called as the point of contact. After that, let us consider an image. In this image, we are having a circle with center O, and we are having a tangent xy. This tangent is going to touch the given circle at only one point, that is point P, and we are going to call this point P as point of contact. After that, let us join center of circle and point of contact with the help of a line segment. We will get a radius. By observing the given statement, we have to prove the tangent xy is perpendicular to the radius OP. That means we have to prove OP is perpendicular to xy. To prove this statement, we have to make some construction. On the given tangent xy, let us consider any point. Okay, we are going to consider a point Q on the given tangent xy. After that, join center of the circle and Q with the help of a line segment. Suppose this line segment is going to touch the given circle at the point R, then we are going to consider OR as the radius of the given circle. After that, let us move on to next step, proof. Here OQ is greater than that of the OR. The reason is very simple, because OQ is the whole line segment and OR is the part of the line segment OQ. Then we already know that part is always less than that of the whole. After that, OP and OR are equal. The reason is again very simple. OP and OR are the radii of the same circle. Let us substitute value of OR in the previous statement. After that, we will get OQ is greater than that of the OP. Hence, in this image, OP is the smallest line that connects XY. Is it right? Because OP is less than that of OQ. That's why by comparing these two lines, OP is the smallest line, or O is having least distance from the given tangent xy at the perpendicular P. Then we also know that shortest line segment is perpendicular to the given line. We learned this concept in our previous standard under the same title, that means under the same chapter, circles. Okay, in that chapter what we have learned? In that chapter we learnt this property. The length of the perpendicular from a point to a line is the distance of the line from the point. To understand this property, let us consider an image. Okay, here we are having a line AB and a point P. After that, consider some points on the line AB, or some infinite points maybe. Here we are considered some points as E, F, M, G, H, I and J, and some more points maybe. After considering these points, let us join the point P with these considered points with the help of line segments. By observing these line segments, which is the least distance having line segment? Okay, after observing or after measuring, we may conclude that PM is having the least distance from the point P to the line AB. Okay, out of these line segments, the perpendicular from P to AB will be having least distance. In mathematics, we define this least length PM as the distance of AB from P. Okay, after recalling this property, let us move on to our original theorem. Okay, by this previous knowledge, that means shortest line segment is always perpendicular to the given line. That means here OP is the only perpendicular line to the given tangent xy. By observing, we may conclude that OP is not perpendicular. OP is the only one line segment which is perpendicular to the given tangent xy. That means OP is perpendicular to xy. After this, we reached the nth proof stage. Okay friends, that's all for this session. Thank you.